started. Okay, John, I will do my best to give you a 1-minute warning. Go ahead.
Okay, thanks. I'm John Schuster from Prairie Crossing Homeowners Association. Next slide, please. We have a lake that was artificially made about 30 years ago, and it's primarily a stormwater retention basin, but it also is an aesthetic enhancement for the community and multiple use for light boating, sport fishing, and some swimming. And also it serves as an endangered species fish habitat by virtue of the fish that were migrated from sanctuary pond. We've got multiple, trade-offs that we have to make in terms of how we treat the lake. Our data set goes back to the original formation of the lake. Jim and his team at Integrated Lakes Management at the time spent 10 years monitoring the lake on a monthly basis. And we have that key report from 2004 gives us a history there. And Alana's team did another one in 2022. We've also done multiple fish studies, and there have been quite a few bathymetric and sediment maps that were based upon various measurement techniques, and that was the subject of a lot of controversy in the community. We did do phase one of a dredging project, and we have since stopped pursuing dredging as an alternative. It may have actually caused us some harm as well. So that's the background on our lake. The next slide shows our watershed. And Lake Leopold is effectively a closed system. If there's sufficient rainfall, it may overflow into the outlet ponds, which eventually go into Bulls Brook. But primarily the water flow is from the surrounding watershed. There's no external water flowing into it. There is a connection from Sanctuary Pond down to the lake. And we have to consider that it's a potential source of nutrients that might affect the overall lake as well. I will point out here the 3 measurement points that we take. There's North Bay, which is the lobe up at the top. There's a southeast outlet, and those each have a little bit different characteristic because of the way they're shaped and the way the water or the wind blows across the lake. And then if you look at where it says BB02 or right near the island there, just above that, that is really the main measurement point that served as a reference back going 30 years ago. So Jim's team used that, Alana's team has used that, and we continue to use that as a reference point to have data that we can go back to. Next slide, please. And after we dredged, 2 years after we had dredging, we had quite a bit of explosion of growth in the lake. We suspect there was a fair amount of sediment that was stirred up. We didn't have that much sediment on the bottom of the lake for the bathymetric studies, and they probably dredged more area than really needed it. So in some cases, we were probably stirring up as much sediment as we were removing. The levels in some cases were quite low and didn't justify it. So I think that was possibly a nutrient issue that's plagued us for about 2 years. Next slide, please. In the fall, after turnover, we do see even more algae, and this is I'll talk about this more with respect to the turnover, but I hope I get time to show. The 2 types of algae there, Jim has done a plankton tow for us. He did it last year, and he was picking up things like this. And I'll refer to that again with what we got this year. Next slide. So based upon an adjustment to our treatment program and trying to take more measurements and paying attention to the lake, we were able to clean things up this year, because subsequent to the dredging in 2022, or prior to that and subsequent to it, really the lake was ignored because our environmental team had broken up at the time. So by going back and paying attention to it and putting some treatments in, we were able to help clean up the beach area and make that swimmable. Next slide, please. So what we found is that from that data, and with the extra time, I'm going to try to go into that a little bit, but we found a primary mechanism that contributes to nutrients is the internal loading coming out from the bottom. And this is something that Jim kind of keyed us on, and he he referenced the book we've used in terms of trying to determine what was going on. So there's not much coming into the surrounding, from the surrounding prairie, because we have a lot of prairie grasses and plants that serve as a buffer. So there isn't that much coming in. We've also got little agriculture in the immediate area that's next to it. So we took measurements that we think determined that that's where our main issue is coming from. Initial measurements in Sanctuary Pond don't show a heavy nutrient load coming from that, but we need to double check that over time. One of the things we learned is that the lake, we sort of assumed it was dimictic, that, you know, you have stratification in the summer and turnover in the fall and spring, and we actually found that that's not the case, that we do have a polymictic lake, if for no other reason than we have two zones that will turn over more easily than the main lake itself. And I'll go into that in the subsequent data. The bathymetric and soft sediment maps that we did again this year, in addition to the one in 2017, really indicate we don't need to do an extensive dredging project. So there may be some benefit in doing a local small area dredging up in the North Bay, where we had to put shoreline stabilization in, and then we could have then dredged some of that material out. But most of this, most of what's on the bottom is coming from plants dying and decaying. And that was the result of prior sediment testing prior to the dredging. That's mostly organic type matter. It's really sort of a gooey sort of sediment. It's not particular in nature. Next slide. One of the other things that we found interesting, and it's a separate companion report, Jim has seen it, is that there's a significant diurnal variation in when we measure. So when we measure is important. So in particular, this year we saw things fluctuate up vertically, and Jim did also a plankton tow this year. He saw things more like rotifers and serradium. I don't know if I pronounced it correctly, but basically we have things that are eating the algae now. So the ecology of the lake is a little bit different this year. But we did note that we have to always try to measure at the same time. We usually get the measurements between 9 and 11 in the morning, but doing a 24-hour cycle of measurements, we found that there's some pretty interesting variations. The measurement, this is maybe sort of an obvious conclusion or observation that it's affected by environmental variables, but in particular, we saw an event this summer where temperature changes drove the lake in a direction that was something maybe we were unexpected. And I'll skip the minor observations for time. We can come back. Those are interesting. But next slide. So what we're going to do with the measurements we took this year is we're going to sit with our engineering firm and our applicator, and we're trying to sit down and formulate a long-term lake management plan. Short term, we'll continue with the treatment program. I'll skip to that later, but we're going to evaluate and adjust that a little bit. One of the questions I'll embed here, well, before I ask the question, I'll mention we did get some curly leaf pondweed observations, so we do have to spot treat some of those invasives. But one of the key things we did was not treat the entire lake, just certain areas that we needed to address to allow for swimming and to keep the algae down. But one of the concerns we have is repeated dosages of sea clear. Do we need to be concerned about copper accumulation? So I don't know if anyone's got a comment on that. But I guess not. Okay. So
I mean, yeah, so copper accumulation will happen in your sediments, and there can be some like toxicity to like macroinvertebrates and those types of things. And what was the first part of your question, John?
Well, if we use sea clear repeatedly, do we need to be? I think what we're saying, we're going to investigate doing more with something like a Utrosorb. We use that here, and what we need to. My final question is going to be, how do we lock up that stuff on the bottom? Okay, that's what I'm going to lead to here. we think we should do more extensive temperature measurements to try to understand what's going on in North Bay and the southeast outlet relative to the main. We took, our goal was to get monthly measurements with the Pro DSS equipment. And then in between that, we have the capability to do temperature and SETI discs. So, and then when we start to see rapid changes, then we do more frequent with Pro DSS, like every couple of weeks. So,
John, St. Clair does not, the claim is that St. Clair actually drops phosphorus out of the water column.
right,
And as I recall, you would identify that's not the case, or it uses something, it does not use any lanthanum or alum to drop phosphorus out of the water column, correct?
right. I didn't
Okay.
say it didn't drop it out of the water. The reference I gave you was that it wasn't using, I think, aluminum or some, whatever chemical
Yeah.
you would acid didn't use that chemical.
Yeah, so there was no specific part of the chemical that was intended to actually bind with the phosphorus and take it out
I
and
think your
gone.
question was copper sulfate, correct? Did it use?
It is, my St. Clair, I believe, is a copper sulfate product, but people that formulate the products have got all sorts of different types of formulations that go along with it. In the case of at least one product that we know, the pH for the copper product is down close to 1. That as a formulated product, that's very different than some of the other things that are out there.
Yeah, all I remember is there was some sort of copper ion chemistry going on, and that was how they did it.
Right.
Okay. This will probably be more meaningful if I show a slide, but we're wondering if we could use a photometer or do a quick measurement of manganese or iron to know that we have our internal loading starting, and then should we try to treat from there? Because part of the problem with these measurements is they take time. What we've done, we have used the Van Dorn sample tube from Lake Lovers. I think it was Paul's actually on loan. And so we would also take measurements along the way because we wanted to add total kilojoule nitrogen and suspended solids to that. And as well as doing the SRT because the photometer wasn't sensitive enough. So we also measured those metals because we were curious about what I can't what her Gertrude, whatever her name is, had suggested in her book indicates that that's part of the process. So we tested those metals.
It's Gertrude Nurnberg is the name of the author. But one of the things that she had talked about is that one of the few sorts of remedies for doing this is to use chemical treatments that pull phosphorus out of the water column and seal them in the bottom. It's one of the few effective ones. And based especially on experience with Paul, one of the things I think you might do is to review the character of those products. There's at least 4 or 5 different products out there that purport to address either water column phosphorus or bottom sediments. And I think that certainly is an alternative, and you have to determine whether that's cost effective. Another thing that I would recommend, just based on things I do know about it, the chara is an interesting plant because it absorbs or picks up nutrients out of the water column. The chara that you've got, the chara by the beach, obviously is a problem, should be dealt with. But what you might do from year to year is to do a small harvest of the chara itself. So what you've got is you've got something that's absorbing the nutrients, that is the chara, and holding it in cellular material along the shoreline. You can harvest some of that, and each time you harvest it, you're going to be pulling more nutrients out of the water column. As long as you don't have more nutrients coming in, then over time, over a long time, that would or could have a potential impact on the phosphorus balance in the lake.
Well, what I'm trying to get to here is that how do we keep the phosphorus from getting in there in the first place? And then the second part is just, if it gets in there, how do you deal with it, which is the chemicals you're referring to?
Well, you shouldn't have an awful lot of phosphorus getting into the lake from shorelines any longer. So the other place where it comes is obviously from Sanctuary Pond. And what are the numbers for the delivery from Sanctuary Pond?
I gotta look up that slide. I have to go to another presentation and pull it. Can I finish my loading presentation here? I want to try to do that. Becky, can we go to?
Should we go to the next slide, John?
Just keep progressing the slides. Yeah, go ahead. I'll go. All right, so quickly, this is just the temperature data that we went through to find out the turnover. Go next, keep going. And we found, okay, you can just step through those because it's animated and it'll go through. All right, so what we found, if you look at the, oh, I'm sorry. So the purple line right here shows that we actually stratified, I actually got rid of stratification in the summertime. And that was based upon when you saw the previous slide, the temperature of the long-term, right, you can see right here. That was this cold spell right here. There also was a prevailing wind that created what I learned is called a seiche. It created a standing wave, and that really addressed, that really amplified the mixing. So we got to this point right here. Then when it got warmer later on, we actually re-stratified again. Now we're going to go out next week and measure. I expect we're going to see this isothermal condition again. So we have this mixing where we're bringing things up from the bottom. Next slide. And associated with that are dissolved oxygen profiles. You can step through each one slowly, Becky. Okay. So we have this going on down here. And when we get that anoxic condition, next slide. Okay, well, this shows that, okay, when we're stratified, this is the green is soluble reactive phosphorus, lab measured. Okay, and it shows that lower depths it's higher, and total phosphorus, same thing, lower depths it's higher when we're stratified. So what we did when this condition was isothermal and it was no longer stratified, as you saw in the temperature and oxygen curves, we said instead of trying to take different locations, we took samples at different depths. It actually showed us that the nutrients had all mixed. So what we believe is going on is when we get anoxic at the bottom, we get the nutrients coming out of the bottom, and then when we have this temperature profile inversion, they get mixed into the lake. Next slide. And next, okay, and this is from the book that Jim has referred to, where the things come out of the bottom layer. And you can, an artifact of this is manganese and iron concentrations. Next slide. So if you look at dissolved oxygen, this is just at the main reference point. The two lobes of the lake, North Bay and Southeast, behave a little differently, but you can see that this is what happens as the season progresses. We get into a very anoxic condition. And when that happens, the oxidation reduction potential changes dramatically. Next slide. And when that happens, we also get higher levels of phosphorus coming out, both soluble, reactive, and total phosphorus. Next slide. And we also can measure higher levels of manganese and phosphorus. So next slide. So these occur at the same time, and we're concluding that that's where our phosphorus is coming from. It's not coming from around, we know it's not coming from the.
Well, that's the question. That is external and internal loading. We understand that you're getting internal loading from bottom sediments. That's pretty clear. The question that I've got is, are you getting any external loading from Sanctuary Pond?
We don't know yet because we haven't done enough measurements. I'm gonna look at another graph here. to
Okay.
get, Um,
For the rest of you, so the rest, for the
all
rest
right,
of the people to
okay.
know,
To answer your question, sanctuary pond levels look like this. Without me going, I don't have that graph in this, but they look like this, okay? And this is what the main lake looks like. So that's why we're more concerned about internal loading than the extra. We are gonna measure sanctuary pond more. But if they're down at this point, that's not driving this up like this, okay? So that's why we're concluding we have an internal loading problem. Okay, next slide.
okay.
And yeah, this is just the overall everything together. That's, you can flip through the rest, Becky. I think we can get up quick. Next. That's historical. See, we're getting, as you see over time, it's getting worse and worse. This is for the month of August. Next slide. Next slide. And this is phosphorus. Next slide. I'm trying to get through next. Yeah, we do measure nitrogen. We measure TKN because we can show that even though the assumption is these lakes are phosphorus limited, we can show that our lake, like in the July-August timeframe, is really nitrogen limited. It's got like 5 to 10 is the TNTP ratio, which less than 10, I understand, is nitrogen limited. So one question we have is, when that happens, does that enhance the ability of cyanobacteria to appear and grow, because they can fixate nitrogen from the atmosphere? That's the question. Next slide. You guys can think about that. Yeah, that next one. I don't want to necessarily talk about it. This is diurnal. Next one. I'm trying to get through. Sorry, Becky. This is probably just the fastest way to get through. Go ahead. Next one. Right. Okay. Thank you. This is our staff gauge. We measure that, and we also measure rainfall. And one of the things we found out, we were just lucky because Alana's team measured the day after we had a big rainfall and picked up a very high bacteria count. So what we do now is we monitor this, and then we have set up with her lab the ability to take our own samples and go over there after a rainfall. So we're doing that to monitor our water quality. Next slide. And yeah, this is it. Next, we can just flip through and get out of this, I think. Yeah, these are our, oh, that's okay. So what we do in addition to that is we test every two weeks. We use one of these. This is antigen test. I think we do a blue-green algae test. So that's what we're doing to protect the water. So the last thing I'll talk to is, what do we do to try to work on we're going to try to use some sort of nutrient reduction strategy in North Bay. I am really concerned about using aeration because I think it's just going to stir things up. When you look at that, look at what's going on there. When you bubble up air is 79% nitrogen. So really what I've been hearing is that aeration primarily enhances flow. So what would be more attractive is something that enhances the oxygen condition at the bottom. So that's really the question that I have, is what's the best way to enhance oxygen condition at the bottom to help avoid this anoxic release of nutrients? And to me, this nanobubble technology seems quite interesting because you've got a case where the geometric length scale of the oxygen particles is much less than the buoyant ones that would convect to the surface, and that stuff's going to sit down there. So the problem is we don't have enough oxygen down there. Let's add oxygen, not try to generate flow and upload nutrients. So that's my final question with that.
And John, I just want to thank you and just see if it's possible. We are right at 5 o'clock right now, team. Are we able to go maybe 1 or 2 minutes over to have some final conclusions, or
Yeah.
should we adjourn? Alana, closing thoughts from you?
Yeah, I was curious about some of the phosphorus data and the hypolimnium because when we were out in 2022, our values were lower. We weren't seeing those as high of values from the hypolimnium. So I'm curious because I know you guys did have some dredging in between as well. I'm just curious about it. I'd like to see additional data too.
Okay, well, we can provide you the North Bay and the Southeast outlet as well.
Yeah. Mm-hmm.
I think that's our concern also, is that we've stirred it up. Okay. So. The dredging, really, we looked at what we did recently from a bathymetric and sediment study showed it's really, dredging didn't have much effect. So. Because there was so little down there in the first place, we just organic, it dies each year.
What's the native material under? Is it again clay? Is it a clay
Yeah.
base or was it a wetland before where it was already nutrient rich?
I think it was an agricultural land, what I had heard.
Hmm.
And there was some wetland around it, kind of similar to what was across the road in Route 45 that they just turned into a wetland prairie. I've seen aerial photographs that showed it was a cornfield. But it's a hard clay bottom.
Okay.
Sorry.
I mean, the other thing I was just thinking about, if that lake doesn't have much outflow, most of what comes in terms of nutrients from the surrounding land that came in over, the past 30 years, and that is just staying there too, and just recycling. So you're not really getting any
Yeah,
removal over.
That's right, Holly. It has, up to this point in time, it has had runoff. And it has had, there's a sewage treatment pipe that broke that fed Sanctuary Pond for a period of time. So one of the reasons that I asked John about whether or not there's anything coming from Sanctuary is the possibility exists that there could still be residual types of nutrients in Sanctuary Pond that might be contributing to Lake Leopold. However, what I think, based on the things in my visits to both Sanctuary Pond and Lake Leopold, is that most of the surface runoff that is represented by the surrounding area has already taken place, and it's not likely to have new stuff in the future. The plant material surrounding the entirety of the complex leading into the ponds is substantial. It's high growth prairie types of plants that exist there, some trees, and so in other words, you've had a naturalized headwater watershed essentially. And so in the future, there should not be lots of new contribution. So what John is dealing with is what has already taken place for the most part.
Measurements that we took in Sanctuary Pond, not only are the water level phosphorus low, but also when we took sediment samples in February from 4 lake areas, the lowest ones really were at Sanctuary Pond. It was like 440 compared to 670 out in the North Bay. So the sediment show like that we had a bunch of residual sewage that accumulated there. If anything's flushing out, it might be Sanctuary Pond more so than the lake, because it can go, that's got elevation that goes down into the lake.
And as a last closing comment for John, I feel very comfortable that the lake and Sanctuary are in good hands for sure.
Thank you.
That is a nice positive. And team, we've gone 29 minutes, and I just want to be respectful of everyone's time. We are 5 minutes over 5. So Mary, I'm going to ask you to conclude the recording for Lake Leopold.